This is a brief introduction to Equal Ripple Opt for Microwave Office. Equal Ripple Opt is a dedicated Chebyshev filter optimization engine that runs on top of Microwave Office, and it communicates with Microwave Office using scripting and the COM interface. So here's a simple edge-coupled filter, N=9 edge-coupled filter, described using the analytical models in Microwave Office. And here's the layout of that filter. And right now the filter is tuned up to be perfectly equal ripple. We can detune the filter. Here's our list of parameters. All the lengths are variables. All the gaps except the last one is a variable. We don't assume any symmetry using our optimizer. So we can detune a couple of lengths, and we can detune a couple of gaps. And now if we invoke the optimizer, the interface is very simple. Just a very few controls here that you have to understand. And if we hit the optimize button, it brings the filter back to a perfectly equal ripple response in just a few iterations. It did about 6 iterations there. Now, a typical problem in filter design is, what if we want to change the bandwidth? We're fine-tuning our filter here, and what if we want to make the bandwidth a little bit narrower? So let's go into the optimization goals, and let's make it 100 megahertz narrower on the high side. Okay, so if we take any of this general purpose optimizers and apply it to this problem as it stands, it won't work very well, because across our region here of interest, the filter is basically perfect already. So it doesn't really know how to modify the bandwidth. The only way we can do that is to add some extra goals out here in the stop band and try to push the S21 response. But with our optimizer, it's actually quite simple. This list of frequencies here are the reflection zero frequencies. They're the frequencies where the return loss nulls occur. And the outer ones are set by the user. The inner ones are output by the optimizer after it finds the equal ripple response. So to change the bandwidth, all we have to do is go in here, and on this upper frequency, we'll move it down by 100 megahertz. And when we re-optimize the filter, it'll make that bandwidth correction for us automatically. Now, the process of finding the equal ripple response is actually an iterative process. So sometimes we may have to run the optimization a couple of times to get it back to perfectly equal ripple. But every time we do that, we're only doing 8 or 9 iterations over here. So in fact, it goes very fast. And it's very robust. It brings us back to the same solution every time. And because the bandwidth has changed, now our return loss has changed. So if we go into the schematic and modify the last gap, which is fixed, if we make that gap a little bit bigger, that should move our return loss up. And of course, changing the gap detunes things. So we'll re-optimize it. And we're very close to our original goal of 20 dB return loss. So that's a very quick look at EQR Opt for Microwave Office, and we'll generate some more videos that show you some more details.